Lecture series of math contest, section 5. In this lecture, we will show how to solve any cubic equations using trigonometric. We will begin with two examples and then go to the detail on how to convert the equation to x cubed plus 3x plus q. We let x equal to 2 cosine t, and then we get 8 cosine t cubed minus 6 cosine t plus 1 equal to 0. Look at this trigonometric function. We immediately have 2 cosine 3t plus 1 equal to 0, and cosine 3t equal to minus 1 divided by 2. From here, we notice we have two places meet this condition. Therefore, 3t equal to 2 divided by 3 pi, and t is equal to 2 divided by 9 pi. So we have first root is x1 equal to 2 cosine 2 divided by 9 pi. Case 2, 3t equal to 4 pi divided by 3. T is equal to 4 pi divided by 9, and x2 equal to 2 cosine 4 pi divided by 9. Case 3, 3t is equal to 2 pi divided by 3 plus 2 pi. That means it goes around another circle. And we get 8 pi divided by 3, and t is equal to 8 pi divided by 9, and x3 is 2 cosine 8 pi divided by 9. Seems this method is very quick. Example 3, x cubed minus 3x minus 18 equal to 0. This example is not difficult because we can use the general method to solve the problem. Say if we let x equal to 3, we know 3 cubed minus 3 multiplied by 3 minus 18. It is 27 minus 9 minus 18 equal to 0. So x equal to 3 is the root. From long division method, we have here x squared, x cubed minus 3x squared, 3x squared minus 3x, and here it plus 3x, it becomes 3x squared, and minus 9x, and this minus this one, it is 6x minus 18 plus 6x minus 18 equal to 0. So it becomes x minus 3 x squared plus 3x plus 6 equal to 0. So we get the three roots using normal method. Now we will use the trigonometric function to solve this equation. We let x equal to 2 cosine t, and then we have 8 cosine t cubed minus 6 cosine t minus 18 equal to 0. 4 cosine t cubed minus 3 cosine t equal to 9. And from this equation, we have cosine 3t equal to 9. Because we use the complex number method, so this is okay. Cosine 3t can greater than 1. Because cosine 3t squared plus sin 3t squared equal to 1. So we have sin 3t squared equal to 1 minus 81, which is minus 80. So sin 3t equal to root 80i from root 5i. For case 1, we have e I3t equal to cosine 3t plus I sin 3t. It is 9 plus I for root 5 I equal to 9 minus 4 root 5. We let R equal to this number and we have E I3t equal to R cube. Because number 1 has 3 cube roots, 1 and this one and this one. For example, E I2 pi divided by 3, 3, and it becomes I2 pi, and cosine 2 pi plus I sin 2 pi, it is 1. So this is also the cube root of 1, same thing as this one. We get the 3 roots for EIT. To be simple, we use R instead. Let us think about the first one. We know EIT equal to cosine t plus I sin t, but we cannot simply say cosine t equal to R. Here, both cosine t and sin t can be complex number. So we can do like this: cosine t squared plus sin t squared equal to cosine t plus I sin t, cosine t minus I sin t equal to 1. And cosine t plus I sin t, we know it is EIT, we can say it is R. So cosine t minus I sin t equal to 1 divided by R. And we combine with cosine t plus I sin t equal to R, and we get equations. And we immediately get 2 cosine t equal to R plus 1 divided by R. And x1, the first root, is 2 cosine t. So it is R plus 1 divided by R. For the second one, we can do the same thing. We get x2 and x3. Please notice, we can let s equal to 9 plus 4 root 5, and s multiplied by r will become 9 plus 4, 9 minus 4, 5. It is 1. That means s is equal to 1 divided by r. Therefore, we can replace 1 divided by r by s. Therefore, we get 3 roots. People may think in the beginning we used to have this one, because sin 3t can also be minus 4 root 5i. If in case 2, say sin 3t equal to minus 4 root 5i, it just switch the location of r and s, and the result is the same. So we only select one case is enough. People may think, hold on, in the beginning we used to use normal method and get the 3 result, and it looks like not the same as this one. How can it happen? Let us verify the first one. For this method, x1 equal to 3, and this method, x1 equal to r plus s. But r is 0.4, s is 2.6, so the sum is exactly 3, so the result is the same. It is consistent. For the other 2 rules, we can verify they are the same as well. Section 3. How to convert a normal cube equation to 3x pattern. First part, we can first convert it to this pattern: x cubed plus px plus q equal to 0. Second, and then we can convert px plus q pattern to x cubed plus 3x plus q pattern. So we do it one by one. For the first one, step 1, let x equal to y minus a divided by 3. And then we have y minus a divided by 3 cube plus a y minus a divided by 3 plus b y minus a divided by 3 plus c equal to 0. And we expand it. Here, this is negative a y squared. This is positive a y squared. So they can be cut off. And this item can be combined. Then we have y cube plus yb minus a squared divided by 3 plus c minus ab divided by 3 minus a cube divided by 27 equal to 0. And this is the pattern of px 加 q. Exactly. Step 2. Assume p greater than 0. We have two cases. One is positive over here, one is negative over here. And we will convert it to different 3x case. For example, we can let x equal to kt. Here, k is a constant, t is a variable. As an example, we consider the first case. We have kt cube plus pkt plus q equal to 0. T cube plus p divided by k squared t plus q divided by k cube equal to 0. We let p divided by k squared equal to 3, and we have k is equal to p divided by 3 root. We can select negative or positive, but negative is enough. And this is become t cube plus 3t plus q divided by k, p divided by 3 cube equal to 0. This is exactly the pattern of 3x. For the case of negative, we can do the same thing and change it to minus 3t plus blah blah. Step 4. We use this equation to get the formula for 3x case. Let x equal to 2i cosine t. And this become 2i cosine t cube plus 3 2i cosine t plus q equal to 0. Because I squared equal to minus 1, it become 8 cosine t cube I plus 6 cosine t I plus q equal to 0. And we have minus 2i 4 cosine t cube minus 3 cosine t plus q equal to 0. And this is cosine 3t. So 2i cosine 3t plus q equal to 0. And cosine 3t equal to q divided by 2i, or minus q divided by 2 multiplied by I. Tip. Someone may think we can have 3t equal to arc cosine, and t is arc cosine divided by 3, and we get 3 values of t, and also we can get 3 values for 2i cosine t, and then we get 3 roots. But because the complex number I is inside arc cosine, so this is not a good way to show the result. It is not suggested. Instead, we will use another more direct method to show the result. Say 3t squared equal to 1 minus cosine 3t squared equal to 1 plus q squared divided by 4. We get two values for size 3t, but as is shown in the previous example, to avoid the duplicate roots, we only need to select one value, which is enough, so we select the positive one. Then we have ei3t equal to cosine 3t plus I sin 3t. Cosine 3t is equal to minus q divided by 2 multiplied by I plus I sin 3t. Sin 3t is root 1 plus q squared divided by 4. So it becomes, we call this part as R, and ei3t equal to Ri, and with this pattern, n can be 0, 1, 2. And we divide by 3, we get ei3t equal to R 1/3 power with this number. And please note, cosine t can be a complex number, so we cannot simplify think cosine t equal to R 1/3 power cosine pi divided by 6. For the first root, when n is equal to 0, we get ei3t equal to R 1/3 power e I pi divided by 6 power. And it can be rewritten as cosine t plus I sin t, cosine t minus I sin t equal to 1. And cosine t plus I sin t is e I t power. So we get cosine t plus I sin t equal to R 1/3 power, blah blah. And cosine t minus I sin t is e negative I t power. So it is R negative 1/3 power, blah blah. So we can put 1 and 2 together. 1 plus 2, we get 2 cosine t. And multiplied by I, we get x1 with this pattern. So this is R 1/3 power, this is R negative 1/3 power. So break it down, expand it, now, and put cosine pi divided by 6 together, and sin pi divided by 6 together, and we get this pattern, this number, and we get x1 value like this. Same thing, when n is equal to 1, so the place become n is equal to 1. Okay, n is equal to 1, so it becomes 2 pi divided by 3. And plus pi divided by 6, it is 5 pi divided by 6. So we can replace pi divided by 6 by 5 pi divided by 6 in this equation, and we get x2 like this. Same thing for n equal to 2. We use n equal to 2, so this becomes 4 pi over here. And 4 pi divided by 3 plus pi divided by 6, we get 3 pi divided by 2. So we replace pi divided by 6 by 3 pi divided by 2, and we get the third root, x3. And x3, obviously, it is a real number. Therefore, we get 3 roots, x1, x2, x3. We can verify it and take this one into the equation, and we can find it is true, it is the root. Summary of the method. It is not suggested to remember the formulas, but we can use the method. Step 1, we can change the cube equation from x cubed plus ax squared plus bx plus c equal to 0 to the pattern of x cubed plus px plus q, or x cubed minus px plus q. Here, p is greater than 0. And step 2, we can convert px pattern to 3x pattern. So negative px go to negative 3x, positive px go to positive 3x. But when we set a parameter for positive 3x, we use x equal to 2i cosine t. For negative 3x, we use x equal to 2 cosine t. And the same thing is we both use cosine 3a, this equation. and we will get the result quickly. Obviously, this method can be used to solve any cubic equations. Please think about it and make more exercise.